This video will cover sampling basics, including populations and inferences, selecting a sample, random sampling, stratified sampling, and cluster sampling. A population is a set of all members about which a study intends to make inferences. Here's a population of people. We'd like to study their television watching behavior and infer how many watch a particular show so we can decide whether to purchase advertising spots during this period of time. But our population is much too large to study effectively. To study their television viewing habits, we'll have to survey them, and it's not feasible to survey every single individual, so we'll take a sample of the population to study. The sample will represent the population as a whole, and so will its survey results if we choose our sample correctly. We will focus on selecting a sample using probability. A probability sample is chosen from a population using a random mechanism. There are two types of probability sampling, stratified and cluster. A random sample is only random if each individual has the same chance of being chosen from the population. So back to our television viewing research. We want to figure out how many television viewers there might be during a particular show. Let's say there are 30,000 viewers in our population. Each viewer is known as a unit. In order to select a sample N of viewers from this population of 30,000, we could choose to use a simple random sample. This means that there's an equal probability that each viewer could be selected for inclusion in the sample. If our desired sample size was 200 viewers, we would find a way to select 200 viewers randomly, and then we could send each of those viewers a questionnaire in the mail about their viewing habits. But suppose various subpopulations within the total population can be identified. These populations are called strata. Instead of taking a random sample from the entire population, we might get better information by selecting a simple random sample from each stratum separately. This is called stratified sampling. Examples of subpopulations in television viewers might include age or gender. There are several advantages to stratified sampling. One obvious advantage is that separate estimates can be obtained within each stratum, which would not be obtained with a single random sample from the entire population. For example, let's say we're looking at our television viewers by age group. We have three strata, 18 to 24, 25 to 39, and 40 plus. We find that their peak viewing times vary based on age. Thus, we can make better decisions about which product to advertise during which time period. A more important advantage of stratified sampling is that the accuracy of the resulting population estimates can be increased by using appropriately defined strata. In cluster sampling, the population is separated into clusters, such as regions of the country, and then a random sample of the clusters is selected. The primary advantage of cluster sampling is sampling convenience and possibly lower cost. Selecting a cluster sample is straightforward. The key is to define the sampling units as the clusters, such as the regions of the continental US shown here. This concludes our video on sampling basics. Today we covered populations and inferences, selecting a sample, random sampling, stratified sampling, and cluster sampling.